everyone. In this video, we're going to focus on complex conjugates. This word that we have here can be spoken as conjugates or conjugates. Complex conjugates of a complex number is a number with the real part and imaginary part equal in value or magnitude, but with opposite sign. Before we jump into this example that we have here to find the complex conjugate of these numbers that we have here, let's have a review on complex numbers. Complex numbers are numbers that can be expressed in standard form, a plus bi. Our a part here is the real part. The bi part here is the imaginary part. Further, a and b are real numbers and I represents imaginary units satisfying the equation I squared is equal to -1. Okay, so let's go over these examples we have here. Determine the conjugates of the following complex numbers. So the first one is z equals 7 plus 2i. Now, if we want to get the conjugate of any number, I'll give you the trick. The trick is to get the conjugate of any number, switch the sign of the bi. So in this case right here, I can go ahead and say that z bar or bar z, this is the notation for conjugate. So if we have a z, that's the original number right there, 7 plus 2i, its conjugate would be equal to 7 minus 2i. So conjugate is that we change the sign of this bi part. So if this is positive, then we change it to negative. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we have z is equal to -6i. So others are going to say like, oh, where is the real part in this complex number? It's pretty much 0. So we can go ahead and write this as 0 minus 6i, but we don't need to write the 0. So then we can go ahead and write its conjugate to be, that's the notation for conjugate, and that is equal to +6i, because again, we only change the bi part, we switch or we flip the sign of the bi part. Since this is a negative, so we change it into a positive. So this is the conjugate for z equals -6i. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. Determine the conjugates of the following complex numbers. So we have here the z is -8 minus i. So then our conjugate here represented as bar z is actually -8. Again, we only change the bi part. So others are going to say like, but there's no b in there. That's actually invisible one in front of it. So that is actually -8 plus i. So this is our conjugate. Okay, now we remember this. If we add the z and the bar z, we get a real number. So if we add z plus bar z, it will give us a real number. Okay, so we plug these values in. Our z is -8 minus i plus the bar z is -8 plus i. So we're expected to have a real number on this. Now we are going to distribute the plus here to each of the terms inside the parentheses. So then this would come out -8 minus i. That's a -8. And then this is a plus i. So then we go ahead and say that a -i plus i is 0. So we can cancel that. And so we are left with -16, which is a real number. So if we add these two, the z and the bar z, it will give us a real number. Now, I want you to remember also this. If we multiply the z and the bar z, we will get also a real number. So I'm just gonna write it down here. Okay, so let's plug this in and see if we get a real number. So let's start with z and the bar z. Okay, so we are going to use the area model for this so that we can multiply these two. We can get the product of these two. So it's gonna be a 2x2 box here, and then in the box we're gonna write first the -8 minus I, and then the -8, and then the positive I. So -8 times -8 is positive 64. And then we have -8 times I is a -8I. negative I times negative 8 is a positive 8I. And then negative I times I is negative I squared. Okay, now we combine like terms, so then these two can get crossed out since we have a positive and a negative. So we are left with 64 minus I squared. So this, when multiplied together, will come out 64 minus I squared. Now we remember that I squared is equal to negative 1. So then we can go ahead and say that 64 minus I squared is negative 1, so I put a parenthesis and I plugged in the negative 1 for I squared. So this comes out 64 plus 1. This gives us 65, which is a real number. So again, if we multiply these two numbers, the z and the bar z, it gives us a real number. And if we add them, it gives us a real number as well. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we start by writing its conjugate. So our bar z, or the conjugate for this, is again, we only switch the sign of the bi. So this becomes 4 plus 5i. So this is the conjugate for this expression right there. So then again, we remember that if we add the z plus the z bar z, that will give us a real number. So then I will show the work down here. Okay, so we got a real number 8. Now, another thing that we need to remember is that if we multiply these two, it gives us a real number as well. So I'm going to show the work down here. Okay, so then we remember that our I squared is equal to negative 1. So I'm going to plug that in here. Okay, so our answer is 41, which is a real number. And then the other one right here is 8. That's it. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!